Hello, welcome to Engineers Mindset Academy. Alright, so let's take a look at this other question, which I also got from Jigjiga University, all the way from Ethiopia. This is a question on construction of a dam. Question says, for an overflow section of a dam with operating head equal to 3 meters and approach velocity of 2 meters per second, where the height of the spillway is 20 meters from the bed. Determine the horizontal force due to water pressure on the upstream face and the dynamic force on the downstream surface of the spillway. Curved surface with radius of curvature 5 meters, internal angle is 60 degrees. Take coefficient of discharge of the spillway to be true. The inflection point on the downstream face starts at 4 meters above the toe bed datum. Alright, so we're given this question. Let's pick out the parameters that was given to us. First of all, they said an overflow section of a dam with operating head. So we have operating head. Okay, we have an operating head, simply called as HO, which is equal to 3 meters, and approach velocity of 2 meters per second. So we are given an approach velocity called that v is equal to 2 meters per second. Okay, where the height of the spillway is 20 meters. So spillway height, we are given spillway height called that h is given as 20 meters. All right, now from the bed datum, determine the horizontal force due to water pressure on the upstream surface. Okay, so we are to find the upstream force. Okay, simply use US. Upstream force is unknown, pressure force due to the upstream surface is unknown, and the dynamic force on the downstream end. So we're also to find downstream force. So let's use d of x for that. Also unknown. Dynamic force due to the downstream end, okay, of the spillway. Now we're given the dimension of the spillway. The spillway has a curved surface with radius of curvature. So the spillway radius of curvature, or simply radius r, is equal to radius of curvature of 5 meters. Radius is equal to 5 meters, and we're given internal angle of 60 degrees. So we are given internal angle, okay, called that theta of 60 degrees. We are given internal angle of 60 degrees. Then take coefficient of discharge. Coefficient of discharge. Coefficient of discharge. Okay, let's simply use CD to represent it. Was given as 2. All right. Okay, so having these parameters now, we are asked to find first the upstream phase pressure force due to the upstream surface, and then the dynamic force due to the downstream surface. Now, calculating this is actually quite simple. Let's start with the pressure force due to the upstream end. To calculate the pressure force due to the upstream end, which is F US. Now, take note, US simply means upstream end. Okay, is equal to 1 all over 2 times specific weight of water in the dam times operating head times the upstream length, all squared. Okay, the spillway length at the upstream, all squared. This is the formula you use to calculate the pressure force at the upstream end. Now, it's also synonymous to the formula using in calculating that of the dynamic force. The only difference now is that at the dynamic force, you're going to multiply the value with what is called the coefficient of discharge, which is given to us in the question. Now, like I said, F of US simply means the upstream. US indicates upstream. Okay, so this is the upstream force due to what? Pressure. Now, this small w is called specific weight. Small w there is called specific weight, and its approximate value, specific weight of water, has a value of 9.81 by 10 to the power of 3 newtons per meter cube. That's the approximate value of specific weight over there. Now, the HO there indicates the operating head, which was given to us in the question as 3 meters, and The LUX that simply means the upstream length. So remember, you're squaring this upstream length, LUS squared, the upstream length. Now this is obtained from the geometry of the spillway. Okay, it is obtained from the geometry of the spillway. So you might be very careful. Maybe you might be told that the spillway is rectangular in section. If it's rectangular in section, then it means the length will be given. But in this case, they said it is curved. From the question, they said that the dynamic force on the downstream end, okay, downstream end of the spillway, then you have curved surface with radius of curvature 5 meter and internal angle of 60 degrees. So which means the geometry of the spillway has a curved surface, and therefore the length, the upstream length, is equal to what? The radius times the theta, the angle itself, but now the angle has to be in radians. Okay, it's simply the radius, the radius of curvature multiplied by the angle theta, but this angle has to be in radians. So all we need to do now is what? Convert the given angle to radians. Now we are given that theta is equal to 60 degrees. So we need to convert this theta to radians. To convert an angle to radians, you simply multiply that angle 60 by pi all over 180. This is how you convert to radians. So the given angle, which is 60 degrees, multiplies pi divided by 180. That gives you the value in radians. So this simply means that if I convert this to radians, I'm going to have, so we're going to multiply, this is 60 by pi, there remains 3.142 all over 180. So this will give us the value of the angle in radians. So theta in radian. We are going to obtain now. Let's multiply that value all through. So multiplying this all through, 60 multiplies 3.142 divides 180. We have 1.0473 in radians. Okay, so this is now the angle in radians. Hence we can now calculate the length of the spillway. Okay, so the upstream length is now equal to, the radius of curvature was given to us as 5. So you have 5 multiplies 1.0473. So this is now equal to, so multiply that answer simply by 5. So we have 5.2367 in meters. So this becomes the upstream length. All right, so having this now, if we know the upstream length, of course, we know the operating head. It was given in the question. Specific weight of water in the dam is a constant value, 9.81 by 10 to the power of 3. Then we can now find the what? Upstream force. Let's do that over here. So I'm going to be wiping this question now. Alright, so let's plug everything back into the formula. Therefore, the upstream force or the pressure force at the upstream end is now equal to, we simply said, 1 all over 2 multiplied specific weight. So you pick it out, 1 all over 2 multiplied specific weight is 9.81 by 10 to the power of 3 multiplied by, next there is what? The operating head, and the operating head was given the equation as 3 meters. So multiply by 3 meters multiply by, next there is the upstream length all squared, and we just obtain the upstream length to be what? 5.2367. So we square that value, multiply 5.2367 all squared. So simply multiplying everything all together. So I'm going to do the random calculation. Okay, I will multiply all through together and give an approximate value for the answer. All right, so you might also want to join me to do the calculation to avoid calculation errors. So we have 403,529.8 newtons. So which means the pressure force due to the upstream end is simply equal to this value. So mind you, I multiplied everything all together at once, not forgetting 5.2367 has to be squared. Okay, multiplied by 3, multiplied by 9.81 exponential 3, multiplied by half, we had this value approximately to be the upstream force. So it's as simple as this to calculate the upstream force due to the pressure, or the pressure force due to the upstream end. Now, to calculate the dynamic force due to the downstream end, okay, it's still virtually the same formula. F d of x, d of x stands for what? Downstream. Okay, so the dynamic force to the downstream end is also given as 1 all over 2 multiplied by specific weight of water in the dam, multiplied by the operating head, multiplied by the downstream length, okay, all squared. This is simply the length of the spillway now, multiply now by what? Coefficient of discharge. So the only thing now is you're multiplying this equation or the upstream force by what? The coefficient of discharge. It's as simple as that. So multiplying simply this by the coefficient of discharge, it gives you the answer. So you might want to either go through the whole procedures, or you can simply say that the downstream force is simply equal to what? The upstream force multiplied by coefficient of discharge. So this is equal to, I'm multiplying this value now, 403529.8 multiplied by the coefficient of discharge was given in the question to us as what? 2. So multiply this value by 2. This implies that the downstream force or the dynamic force due to the downstream end is simply equal to, let's multiply that value by 2 and see. So we have 807059.68 in Newton. So this becomes the dynamic force due to the downstream end. Alright guys, so this is how you calculate it. So you can either simply say that the dynamic force is equal to, by putting in the values, this is 1 all over 2 multiplied by specific weight, which is 9.81 by 10 to the power of 3 multiplied by the operating head, which remains 10. Of course, we obtain the value of the length here as 5.2367 all squared, but not forgetting now, you multiply by the coefficient of this charge, which is 2. So whichever way you go through this, you will see obtain the same result, or you simply multiply the upstream surface force by what? Coefficient of discharge, and you obtain this answer. So that's how you calculate the forces, the pressure force and the dynamic force at the upstream end and the downstream end. All right, so that's it. So now in the second question, if you need the solution or the guidelines of how to tackle the second question, you might do well to, of course, DM me on my WhatsApp, and let's talk about how you can be able to tackle the second question. I will see you in the next videos. Thanks and cheers. Please, if you're new to the channel, do well to always like our videos, comment, and of course subscribe to our channel. It does us a great lot of hope, to keep making videos for you guys. I will see you in the next video. Thanks and cheers.